Alright, let's take a look at an actual example. So find example 6 in your notes packet and we'll work it out. So in this picture here you can see that you've got a negative charge on the left side there and a positive charge on the right side, and it's asking for the electric field that they're going to make over there at point P. Well, okay, if you're thinking to yourself, as people frequently do when they start electric field problems, but what's at point P? Is there a positive charge there? Is there a negative charge there? We'll get into that later on in the question, but it's actually not really relevant. It doesn't matter what's there. That's not how you determine what the electric field is. The way you determine the electric field is, like we talked about in the previous video, by drawing arrows, which, if you remember, is the same way that we started things off when we were doing force problems. When you had two forces acting on something, you had to draw arrows to decide whether or not the fields were going to add or subtract. So the plus 2q at point P is going to make a field that will go, if you recall, away from itself, because positives make fields that go away from themselves. Alright, so there's that. And then in red I'll do the negative charge. The negative charge is going to make a field that goes towards itself at that point. Alright, so remember, which way towards and away from happens to be depends on where the point is. Alright, so if I'm at P and I want to make a field that goes towards the minus Q, because that's the kind of field the minus Q will make, well, that would be an arrow to the left. Alright, so the plus 2 is making a field to the right. The minus Q is making a field to the left. If at this point you're still thinking, but Mr. Erico, what is an electric field? I'm not following all this. You know what? It's alright if right now you don't completely understand what those are. I will help you with that when I have returned to school. What I really want is for you to be able to at least calculate them. If you don't understand what they are, we'll deal with those misunderstandings when I return. Alright, but if you can at least calculate it, then we've got something to go off of. Alright, so if you feel like you are able to draw an arrow away from a plus and an arrow towards a minus, then you're actually off to a pretty good start here. Okay, so now we get to part B. It's telling us what the charges are. Well, sort of. It says Q equals 1 microcoulomb and D equals 1 centimeter, and we're supposed to find the value of the field at P. And what's going on there? Okay, well, if Q is 1 microcoulomb, then that means negative Q is negative 1 microcoulomb. Okay, and the plus 2q must be plus 2 microcoulombs. Okay, alright, so I'm going to call the field from the negative charge E, how about E1, because why not? I know it's not the first arrow I drew, but I'll do it in red, that way that'll work out. Okay, so the electric field from the negative Q is going to be, let's see, my equation was KQ over R squared. K is 9 times 10 to the 9th. Q was, well, for the negative Q, it's negative 1. Oh, get rid of that negative there. 1 times 10 to the negative 6. Remember, we don't plug in the signs of the charges when we are working out electric fields, because if I were asking about a different point, the direction of the field would be different, not because it's a negative charge, but because we'd be looking at a different point. Okay, so 9 times 10 to the 9th, 1 times 10 to the negative 6th, and then R. It says it's 1 centimeter. Continue to not be taken in by centimeters. Like with the gravitation unit, it's one of the few dirty tricks that I have to play is messing with the units. So that means that you gotta make sure you put centimeters into meters. Okay, so if we multiply this all out, the field's going to come out to, let's see, 9,000 divided, okay, so 9, that's supposed to be the number 9. All right, 1, 2, 3, 4, 5. That is a lot of zeros. All right, and take a moment and think, what were the units? What did Mr. Hero just say they were? You do need to know the units for an electric field. You can figure them out, but this is one of those units where you got to memorize it, and you can bet that in a given problem on the test, you're going to have to do newtons, newtons per coulomb, and you got to know which one is which. So force is still newtons, electric field is newtons per coulomb. All right, now we're not done. That's the electric field that the negative charge makes at that point. That's not the electric field at that point, because there's two charges making a field at that point. So now we've got to work out what the 2q's field is. And then we have to figure out if we're adding or subtracting, which you may already have guessed the answer for that. Okay, so same equation, kq over r squared. The charges, or the charge for this part of the field is 2 microcoulombs. All right, and the distance. Oh, you guys. Well, I guess if you already noticed that I messed up the distance on E1, good for you, because I did. Let's finish working this one out, and then we'll go back and fix that one. Okay, so this one is 1, 2, 3. So many zeros. 1, 2, 3, 4. That's supposed to be a comma, comma, comma. I hate writing with my finger. Newtons per coulomb. Okay, so back up to E1. Well, I fell error to one of the frequent mistakes that students make on this, which is not adding up the distances correctly. 0.01, 1 centimeter, is this distance, not that distance. So actually this should have been 0.02. Alright, which would have made my answer here not 90,000. That should have been 45, whatever it is, 45 million. It's a lot of newtons per coulomb. Okay, so no, I mathed wrong again. I should not have divided by 2. I should actually be dividing by 4. You guys, this is just not my day, is it? Okay, so 9 divided by 4. You guys can do this in your calculators, I guess. 225,000,000. There we go. All right, much better. Maybe I shouldn't be doing this at like 6 in the morning. Okay, so 22,500,000. Let's see now. All right, so that's still not, neither one of those is the answer. The question was, what is the field at P? Those are the fields that each of those charges alone would make at that point. So now I need to figure out if I'm adding those fields together or subtracting them. Well, if you remember from force problems, when we drew the arrows, if the arrows went in opposite directions, that meant that they were opposing, and therefore the fields would subtract. So I'm going to subtract those two fields. I don't know why I put my minus sign there, but whatever. So then we're going to end up with 1, 5, 7, 5, 0, 0. And if I make a mistake, please excuse me. I'm not going to go back and fix it again. All right, newtons per coulomb, I think. Okay. And of course, you could put that answer in scientific notation as well, and it would be just fine. Okay, so that's the electric field at P. Now, just for the sake of argument, before we move on to part C, if this charge had been a plus Q, the only thing that you would have done differently during the course of the whole problem is the red arrow that I drew right there would have gone to the right, and therefore this would have been addition instead. And so we would have had, a different answer here that would have reflected adding the two fields together. That would be the only difference. Now finally, at last, part C is asking us for the force on a charge. Okay, so finally, we're asked for force again. And so you may be thinking, wonderful, Coulomb's law, KQQ over R. Nope, nope, don't do it. Do not do it. If you already went to all the trouble of finding the electric field, the way to find force is not with Coulomb's law, it's with F equals QE. This is one of those rare moments when physics is easy. Meaning, you literally just need to multiply two numbers together, and you will have the answer. Alright, so it says a charge of -2 nanocoulombs is placed at P, and we're supposed to find the magnitude and the direction of the force that acts on it. Well, alright, the charge is 2 nanocoulombs. Okay. We'll deal with the negative sign in a minute, so just hold on there. And then the electric field that we got from the previous part was 1,575,0,0,0,0. Okay. Alright, and so now we can multiply those two numbers together. Oh man, my head is spinning at the thought of multiplying by 2. Let's see, so we'll have, mostly just because this is all in scientific notation, I'm trying to do this live. Hang on. Alright, I think that's the right number. If it's not, please excuse me, I don't have a calculator in front of me. Okay, so magnitude of the force is that. Don't forget your units. Force is measured in, let me think. It's measured in, come on y'all, it's measured in newtons. That was supposed to be the stuff. There we go, newtons. Okay, now I am always going to ask magnitude and direction. There it is where it says direction. Now I forgot to write down the direction in part B. Alright, so if you look back up at that for a moment, the direction of the total direction of the field is to the right. Because out of the two fields that you had there, the one that was going to the right was the 180 million one, and so that was the bigger field. So that means, you know, since you subtracted them, the bigger field wins, and so the field was to the right. Okay, so the field is to the right. That doesn't mean that the force on a charge placed at P is to the right. That means the force on a positive charge would be to the right. I said that this was a -2 nanocoulomb charge. So that means that if the field is to the right, the force is to the left. And there it is. So 0.315 newtons to the left would be the force on the -2 nanocoulomb charge. Now, if it had been a +2 nanocoulomb charge, the only difference is that it would have been to the right. That's it. That would be the only substantial difference. The direction would be opposite. All right, now the inexplicably part E, because there's no part D for some reason. We'll worry about how to identify positions where the electric field could be 0 next time. So there you go. You're done. You should be able to do everything on your homework based on what we have talked about so far. So good luck, guys, and I'll see you next class.